Right. Let us try another example regarding the curtailments of reinforcement bar in simply supported slab. As compared to the previous two examples, this one resembles the other condition. Without further ado, let us get started. This is the simplified rules for the curtailments of reinforcement bar in the simply supported slab. Given the dimensions of the slab, Lx 5.75 meters, Ly 7 meters, and the thickness of 225 mm. Remember, the thickness exceeding 200 mm, you will use different approach to determine the maximum bar spacing. Assuming this slab is heavily loaded and the effective span is relatively large, through the calculations, you need the reinforcement to be more heavily reinforced. Let's say now your initial proposal for the reinforcement is H10 100 for the main bar and H8 150 for the secondary bar. Now we will look into the solution. Given the dimensions of the slab, the main reinforcement bar, it will be at the shorter span, which is in the spans of 5.75 meter. You're providing H10 spacing at 100. As for the secondary reinforcement, which is at the longer span, your intention is provide 8 mm diameter at a spacing of 150. Bear in mind that reinforcement bar, which we normally use in the slab, the minimum size it will be 10 mm. You cannot use any reinforcement less than 10. I believe you have R8 bar, but you don't have H8 bar. R8 bars are the mount steel bar, which is normally used for the shelling. In local industry, we never use H8 bar as the reinforcement for the concrete structure. Let's say we keep the spacing by just increase the bar size from 8 mm diameter to 10 mm diameter. We will use this reinforcement bar for the following calculations. First, you can check whether the AS minimum is fulfilled. Use this formula to do the calculation, which we have discussed in our previous video. Your B here represents the unit width of 1 meter, as the slab is typically designed on the basis of 1 meter unit width. The effective depth is calculated by minusing the thickness of the slab with its nominal cover, which in this case your nominal cover is 30, and then minus half of the bar size. As for the effective depth for the secondary reinforcement, thickness of the slab minus the nominal cover minus the size of the main bar, which is 10 mm, and minus half of the bar size. And then you can get the FCTM either by referring to Eurocode 2, table 3.1, or adopt the formula. The concrete grade is 30, therefore you use this formula. Substitute the value into the formula, you get the SCTM equals to 2.9 Newton per mm square. Substitute all the relevant value into the formula. You get your AS minimum, which is 287 and 271 for the main and secondary bar. The provided amount of reinforcement bar is greater than the AS minimum. That means it is acceptable. Now you would like to check for the maximum spacing. Since the thickness is more than 200 mm, you're going to use this formula to calculate the stress in the steel bar. And then, based on the stress of 10, refers to table 7.3n in Eurocode 2. For the crack width of 0.3 mm, you get the maximum bar spacing. Now let us look into the calculations. This is the formula to do the calculations. You know your FYK, which is 500. You need the GK and QK that you use to compute the loading. Let's say these are the GK and QK. Assuming you are not intent for any redistributions of the load, that means your gamma here will be equal to 1.0. Substitute the GK, QK, and FYK into the formula. You get the stress in the steel bar equals to 169 Newton per mm square. Refers to table 7.3N in Eurocode 2. 169 is somewhere here. That means your maximum spacing, it will be somewhere between 250 to 300. You can do interpolations based on the stress in the steel bar, which will give you the maximum spacing of 289. Or you can use a more conservative approach without doing any interpolations. Choose a critical maximum spacing. 169 is between 160 and 200. That means your maximum spacing is either 300 or 250. Which one it will be more critical? The closer the maximum spacing, it will be more critical. Therefore, you can choose 250 instead of 300. In this case, we use the interpolation methods with the maximum spacing of 289 mm. Now compare the maximum spacing against the spacing that you have provided. The spacing is acceptable. With that, now you at least know that the proposed size of the reinforcement bar and the spacing is adequate in terms of the maximum bar spacing and also in terms of the minimum bar area. One more thing that you might want to check, it would be checking the areas of the secondary rebar against the main bar. The secondary rebar should not be less than 20% of the main bar. By looking at the ratio here, you know that the secondary rebar is about 66.8% of the main bar. Then you know that you have no issue with the 20% of the main bar. Now you have the main and secondary reinforcement more or less confirmed. Your next step, it will be the curtailment. You will look into the options that you have, compare against the simplified rules. The simplified rules allow you to reduce the reinforcement bar by half near to the support. We mentioned it previously. The easiest way for you to do that, it would be do the curtailments of reinforcement bar at this place. Curtail one of the bar every 2 bars. You do the curtailment alternately. As a result of the curtailment, at the midspan, you will have #10 100, whereas at the support, you will have #10 200. Before you decide on the curtailment, there is 2 things that you need to check. After you've done the curtailment, the spacing here become 200. Check against the maximum spacing. The maximum spacing is 289. That means your 200 mm spacing is lesser than the maximum spacing, which is acceptable. Second thing you need to check, it will be the AS provided. When your spacing reduced to 200, your AS provided, it will be 393. Compared to the AS minimum, which is 287, your AS minimum is also passed. This allows you to do the curtailments and make it #10 200 with the AS provided 393 near to the support of the primary reinforcement. Next, you will need to get this distance to find the exact locations where you do the curtailment. Your effective span in the shorter span, it will be 5.75 meter. 0.1 times 5750, you get 575 mm. That means the distance from the support, it will be 575 mm, where you can do the curtailment for the main reinforcement. This will be the final outcome. How about the secondary reinforcement? We will do the same process here, also checking the maximum spacing and also checking the AS minimum. If either of them fail, you will stick with the same amount of reinforcement bar throughout without doing any curtailment. Now let us look into the options. You want to reduce the areas by half. That means you do curtailment here and here. Do it alternately. Every 2 bars, you cut 1 bar, leaving you double the spacing. The spacing here becomes 300 mm. Check against the maximum bar spacing, which is 209 mm. That means it doesn't pass the maximum bar spacing. You may also check the AS provided against the AS minimum. Let's say now you choose to use 300 mm. Your AS provided is 262. Compared with the AS minimum 271, obviously it fails. Therefore, both maximum spacing and the AS minimum do not allow you to do the curtailments for the secondary reinforcement. This shall lead to you no curtailments for the secondary reinforcement, and you can do curtailment for the main reinforcement. This is how the reinforcement bar will look like after the design. This will be the main reinforcement bar stretching along the shorter span, which is 5.75 meter. You do curtailment alternately for the reinforcement bar at the locations of 10% of the effective span, which is 575 mm, giving you the layout of reinforcement bar, something like this. As for the secondary reinforcement, no curtailments apply, as this will have issue with the maximum spacing as well as the AS minimum. Now you might want to ask, why do I have to double the spacing if you want to reduce the amount by 50%? Can't I just simply increase the spacing, maybe by 50 mm, so that it passes both the maximum spacing as well as the AS minimum? Or probably I increase to 250. The maximum spacing still pass and the AS minimum still pass. Of course, you can do that, but it is not realistic. Let me show you why. To avoid confusions, maybe let us first delete the main reinforcement to make it clearer the situation. This will be the layout of your reinforcement after you've done the curtailment for the secondary reinforcement. Initially, in the midspan, your reinforcement it will be #10 150. That means this spacing it will be 150. Then you can do the curtailment. That means you're going to cut the reinforcement bar here with the intentions from here onwards. The bar spacing has been revised into #10 250. This 150 spacing and 250 spacing, they are not consistent. That means at the end of the day, the layout of the reinforcement bar, it will look something like this, near to the support. Now, you cannot simply put the reinforcement bar something like this, as there will be issue with the development of the stress and transfer of the stress between the reinforcement. If you put the reinforcement here without any lapping, it will be as if these regions there is no reinforcement. You need a certain degree of lapping length for you to have the stress effectively develop along the lapping length. This lapping length will lead to a waste of the material. This is the second issue. First issue here, it will be the random arrangement of the reinforcement bar here. Doesn't seem consistent with the initial spacing. Second issue, you need the lapping length. You have one more issue here. We discussed about the principles of doing lapping of the reinforcement in our previous videos regarding the curtailments of reinforcement bar in continuous beam. For stress to effectively develop from 0 to the full stress, a full lapping length will be required. Now, if you intend to do the lapping here, in order to ensure full stress is developed, the curtailment of the existing reinforcement at the midspan will theoretically not happening here. It is very likely for you to cut your reinforcement bar somewhere here, so that the lapping length will be sufficient for the stress to fully develop. In order to ensure starting from this point onward, you get 100% of the rebar. At the end of the day, the locations where you're going to cut the reinforcement, it will be 0.1 times the effective length minus the required lapping length, which may lead to you a situation that the lapping length can be longer than this one if the effective span here is relatively low. This is the third situations that leading to you in practical to have the curtailment of the reinforcement bar at the spacing inconsistent with the midspan reinforcement bar spacing. Because of this 1 through 3 situation here, might as well you don't do any curtailment, leading to you the final layout of the reinforcement something like this. Simpler to construct and easier to monitor.